Hello, everyone. Thank you for joining today's webinar on Planning MRI Suites Simplified. My name is Brandon Taylor. I am the Key Accounts Director for Metrasens. For anyone not familiar with us, we are an advanced magnetic solutions company, and we specialize in safety applications, including MRI. Today with me, I have Tobias Gilk of RAD Planning, who we are very excited to have run through today's presentation. Before we begin to cover some quick housekeeping items, on the top left of your screen, you'll see the media player. Please use this to adjust volume. On the bottom left-hand of your screen, you will see a question submittal form. Please do submit any questions you have throughout the presentation, as we will have a Q&A at the very end. The larger center window will be the main presentation screen to follow throughout today. In the top right window, we have downloadable resources that form the basis of today's webinar. Please don't forget to take those before you leave. The bottom right window has bio and connection details for both myself and Tobias. And finally, we have the bottom control bar. This can be used to minimize or recover any of the windows we just went over. With that, I will turn it over to Tobias. Tobias, please take it away.
Thank you very much, Brandon, and welcome to Planning MRI Suites Simplified, Metrasens MRI Suite Planning Resources. My name is Tobias Gilk. I'm your presenter for today, and let me first start out by giving you a little bit of information about me. So, I am an architect with the firm RAD Planning, or Radiology Planning. I'm a founding board member of the ABMRS, the American Board of Magnetic Resonance Safety. I am a special consultant. Actually, I guess now I should say was special consultant to the ACR's MRI Safety Committee. I served the committee twice, once for what became the 2007 ACR guidance document on safe MR practices, and once again for what became the 2020 manual on MR safety. That second document, the 2020 manual, is available for download from the ACR's website, and it has some really good facility information. There's an appendix at the end that really kind of narratively walks you through an MRI suite from a safety standpoint. Not listed on this slide is the fact that I'm also a member of the FGI, the Facilities Guidelines Institute, folks who write the healthcare design standards that are used widely throughout the United States. In addition to those, I serve my own consulting company, Gilk Radiology Consultants, and the standing client that GRC has is Metrasens, in addition to providing sort of individual case-by-case client services to hospitals and healthcare providers related to MRI. So that's a little bit about my background. Let's jump into the material. Well, jump into the material right after we take care of the lawyerly stuff. And one of the first lawyerly things is ABMRS content disclosure. Because I'm a board member, I am precluded from talking about specific examination content or examination questions. This is not that. This is on generalized MRI suite safety, design and construction related concepts and principles, which is squarely within what I am permitted to talk about. So what is this webinar going to cover? We're going to talk about the fact that designing MRI suites is inherently a complicated task. It is a difficult ask of equipment planners, architects, engineers, planners, and then the construction of these facilities is similarly complicated and difficult for general contractors and builders. But Toby, OEMs provide us design templates that should answer all of the questions we have, right? And that'll be the second topic. The third one will be, wait a second, we've got a plan for an MRI that we did some time ago, right? I mean, an MRI is an MRI is an MRI. We can just kind of reuse those existing plans, can't we? Then we're going to talk about some of the multiple overlapping and sometimes conflicting standards that you will find that really guide or direct the design and construction of MRI facilities. And then at the end, we're going to describe a new set of resources, the Metrasens MRI Suite Design and Construction Planner, and talk about some of the corollary resources that are available along with that. First, we're going to state the obvious. Designing MRI suites is a complicated undertaking. We have to deal with healthcare code requirements, general building code requirements that probably layer on top of whatever the health code design requirements are. State licensure, and your state licensure may reference existing healthcare design standards or code requirements, and likely invokes general building code requirements as well, and may layer on top of that some of its own homebrew expectations. Then we have accreditation requirements. And if you're in a hospital, you're probably dealing with enterprise level accreditation like Joint Commission or DNV. If you're an outpatient imaging center, you probably are dealing with ACR or IAC modality level accreditation. And if you're in a hospital and you have both enterprise and modality level accreditation, you probably have a bit of both. And ultimately, we're designing these spaces to serve clinical function. It's easy to get bogged down in the minutia of codes and standards and chapter such and such and verse so-and-so, but ultimately we're designing this for patient care. So understanding clinical operations is an essential ingredient to effective MRI suite planning. So to that end, to the importance of understanding clinical and the clinical folks understanding what the design and construction team is all about, we need a Rosetta Stone. We need something that allows communication to effectively flow in both directions, because this is really vital to effectively plan suites. Clinical people need to understand design talk, design speak of architects and engineers and equipment planners. And you, architects, engineers, equipment planners, you need to understand what the clinical personnel, what their concerns are, both in terms of how they take care of patients clinically and just the logistics of who their patients are, how they come there, what they need to do to them. All of these things really go into planning effective and efficient MRI suites that also happen to protect the safety of both patients and staff. Here's one of the underlying problems about MRI suite design and construction. We have a ribbon cutting day, right? So you see the ribbon running up and down the middle of the slide, and we're cutting it, and there's a big celebration, there's cake and punch, and everybody is patting each other on the back about how beautiful your brand new MRI suite looks, right? This is the day when the clinicians show up and they take over the space, and it is theirs henceforth and evermore, right? This is the day that the design and construction team walks out the door. The disconnect here is that the design and construction team is doing everything in anticipation of this moment, but they're not there to see it. Not the moment of ribbon cutting, the moment of actual patient care, that first patient who comes through. And whether or not the facility is actually effectively laid out to meet the patient care needs, the operational needs, that is what drives effective MRI suite planning, design, and construction. We need to close the loop. We need it such that ribbon cutting day is not the last day that the design and construction team thinks about an MRI suite. We need to think about it in terms of how it operates for the clinical and operational staff after ribbon cutting day. Which brings us to our first audience poll question. This is both for designers, but it's also for hospital personnel on the call. When you're designing an MRI suite, which is your single biggest resource, right? The initial planning stage, setting out the broad brushstrokes of your MRI suite. Is it vendor templates provided to you by Siemens, GE, Philips, Canon, whomever. Do you rely most on those? Do you rely most on building codes and standards, healthcare design standards? Or do you rely most on sort of the end users? I'll give you a couple minutes. Click the radio button, the circle on the left of the answer that most closely matches yours, and we're moving. But the OEMs provide templates, right? The OEMs, they provide us what we need. They give us floor plans. So, Toby, you're making this sound a whole lot more complicated than it is. I just download this stuff from the vendor's website, and I'm good to go. So, okay, what's in those vendor templates? Typically, a vendor template for an MRI will include the scanner room, the control room, and the equipment room. And that's it. Here's an example. I don't mean to pick on any one vendor. This is GE just makes their stuff really easy to find on the web. This is one that I had downloaded some time ago. And on the left is the control room, sort of center. You see the magnet room. At the top of the diagram is, well, there's an equipment room, and over the years, GE equipment rooms have been able to get smaller and smaller, so they were left with this leftover space, but now they have a reading station right outside the door to the magnet room. I don't think I've ever seen an MRI suite design that has the radiologist essentially parked right outside the door to the magnet room. I've seen them across the hall, but not right outside the door. So is this everything we need? Okay, where do we receive patients? Where do we check them in? Where do we collect their insurance information? Verify their pre-authorization? Where do we do the interview of the patients? Check them for clinical contraindications. Do you have the pacemaker? Have you had brain surgery? Where do we conduct that clinical interview? If we're gowning the patients, where do we gown them? If they have belongings that they want to lock up, where do they put that? If we're giving these patients contrast, where do we store and prepare patients for the contrast? Are we doing pre-injection catheters? Or are we doing everything with butterflies in the magnet room? None of these questions about the spaces needed to support the ancillary and support functions for MRI, none of those are shown in this suite layout diagram from the OEMs. And it's not their fault. I mean, yes, I suppose they could show us that, but their job is to sell us a product. And these happen to be the rooms that host their product. They don't sell reception desks. So if we just constrain our view to these rooms, to the magnet room, to the patient care area, how does this design change if we have high acuity patients? Patients from your ED or trauma, right? What about the stroke patient, cord compression? What about the patient on a ventilator from the ICU? Are there reasons that we would modify the vendor-provided diagram or prototype based on patient acuity or level of intervention? A second bullet point. What if we're doing image-guided breast biopsies, right? What if we're doing MR-guided focused ultrasound? Does the room layout, space allocation, equipment in the room, does that change when our clinical needs change? What about future equipment replacement? If the room that they show is sort of the minimum configuration for this machine, and 10 years from now, it's reached its end of life and we're replacing it with something else, does this design anticipate and facilitate that future equipment replacement? COVID, for God's sakes, we're going through one of the biggest infection control tests of healthcare facilities. And quite honestly, a lot of radiology has been failing the test. We have not been being as diligent about infection control, infection prevention in radiology spaces as perhaps we ought. So these are some of the ways that our prototype template designs really don't get down to the nuts and bolts of what we need from MRI facilities. So let's take a look back at your answers. Okay, all right. So I asked, when planning and designing an MRI suite, which is your biggest resource? Vendor templates, codes and standards, end user input. Okay, all right, I see you guys. We will talk more about this at the Q&A if we need to. Thank you for your answers. While we're doing audience participation questions, let's do another. So, figuratively speaking, if you have an MRI suite design, let's say somebody planned an MRI suite 10 years ago, right? And the funding didn't come through, but you had paid the architect to do the designs, and they just stuck it in a drawer somewhere. And 10 years later, somebody drops a big bag of money in your lap and says, okay, now go ahead and do that MRI project that you planned for 10 years ago. If you pull those MRI suite designs out of the drawer and now you're prepared to use them, right? How relevant, how old or outdated are those plans that were prepared 10 years ago? Are they most likely ancient and really, not worth the paper they're drawn on? Not ideal, but yeah, in a pinch we can make it work. Or it's an MRI. It was an MRI 10 years ago. It's an MRI today. We'll brush the dust off of it and call it good, right? So if you were to today be building an MRI suite based on plans that were developed 10 years ago, would you recognize those plans as being positively ancient, not ideal, but it'll do, or let's just roll forward with it and not worry about it? Click your answer, make sure you hit the submit button, and we're moving. So, to the question of recycling prior designs. We can just recycle the prior MRI siting plans, right? Well, I hope that we've learned a little something about the value of sort of identifying contemporary needs from when we were looking at vendor templates. MRI scanner technology has changed rather substantially in the last 10 years. Certainly over the last 20 years, and lots of the vendor templates really have not undergone a significant update based on any of these factors in 20, 25 years. So we have changed the MRI scanners. The financial environment in which we deliver MRI care has changed dramatically, the operational model. Reimbursement has cut dramatically. We have reduced staffing in response to that to try and reduce operating costs. We have increased throughput to try and jack up revenue to offset the decline in per procedure reimbursement. Clinical utilization. We are doing higher acuity patients, patients with different implants and devices. Clinically, the patients that we see in MRI today is so profoundly different than patients we saw in MRI 20 years ago. Yes, we still see the walkies, talkies, knees, and heads that were predominant 20 years ago. Those still make up a good proportion of our MRI studies today. But we also have the pacemaker patient and the ED patient and the image-guided breast biopsy and you get the idea. Plus, just our codes and standards about building new facilities has changed pretty dramatically. So, please, please, please do not recycle prior MRI suite designs. Now, that doesn't mean that you throw out the good ideas that you had from 10 years ago or whenever. Absolutely, recycle good ideas, just don't recycle the whole plan. Reassess your needs and redevelop a plan based on those needs. So, how old is a 10-year-old MRI suite design? Let's see what you guys think. Is it positively ancient? Is it not ideal, but it'll do? Is it brush off the dust and go? Okay, all right. Again, if we want to, we will talk about these in the Q&A period. I'm going to try and make sure I preserve plenty of time. So, multiple standards. This is one of the challenges of MRI suite design. We answer to multiple masters. Healthcare design codes. If you have a choice of what healthcare design code you wish to use for an MRI project, please, please, please use FGI 2018, or in just a few months from the airing of this initial webinar, there will be a 2022 FGI available. Please, for MRI, use 2018 or later. The FGI 2018 substantially rewrote imaging and made the design standards, I think, more responsive to contemporary MRI. So we have to follow a healthcare design code. If you have a choice, choose FGI. Building codes, International Building Code, Canadian Building Code, California Building Code. There are lots of different generalized building codes that have hospital and healthcare criteria. State licensure requirements. Your state license may have its own design and construction requirements. More than likely, it invokes one of the two above, healthcare design codes and building codes, and maybe mixes it up a little bit of homebrew, a little bit of standard. We also have federal standards if you are a federal facility. So the VHA, Veterans Health Administration, has its own standards for radiology and MRI suite design and construction. Plus, whoever the accrediting organization is, Joint Commission, DNB, whatever, ACR, there are going to be compliance standards built into the accreditation regime that pertain to the physical environment. So we have to comply with those as well. So all of these external standards that I mentioned are in addition to basic minimum siting guidance from your OEM, your original equipment manufacturer, as well as the end user needs. What I would suggest is you really want to start with the last thing I have put on this list. You want to start with the end user needs, the expectation of how this facility is going to operate when all is said and done, after ribbon cutting day. And then back into this sort of grand design, grand scheme of operation, information such as the OEM minimum siting criteria and building codes and standards and accreditation criteria and that sort of thing. My recommendation is to always hold up the operational model as the ultimate goal. And sometimes we have to make compromises based on codes and standards and accreditation minimums. So we can't always get to our idealized state, but we want to at least define that idealized state. So where to turn for information, for resources, for help? Now, you can turn to lots of separate little books and texts and websites to kind of pull things down. You can have NFPA 101 and IBC. You can have FGI. You can have ACR and Joint Commission. You can have your state codes and standards. You can wind up with a desk that looks like something from a medieval library covered in books and scrolls and whatnot. But if you're looking specifically for MRI information, that's a page or 2 pages probably out of each one of those 6 or 8 or 12 different reference manuals. So that's a whole lot of books for not a whole lot of pages. So where can you turn to get centralized information about best practice for MRI suite design? Well, that's funny that you should ask such a question, because this webinar happens to be all about the new Metrasens MRI suite planning tools. What is in those Metrasens MRI suite planning tools? Well, we actually started with the VA Imaging Services Design Guide in terms of some of the graphics. The VA Imaging Services Design Guide gives a design for a changing room, a design for medication prep and IV start. It gives a separate design for an inpatient holding bay. It gives a separate design for an MRI, scan room, control room, equipment room. What it doesn't do is it doesn't give you a suite. It doesn't take all of these elements and kind of glue them together. We have done that. We've actually built you 3 different suites. We have a small one that's really more prototypical of an outpatient imaging center. We have a small one that is a small 1-magnet hospital type of setting. And then we have a 2-magnet, which could be expanded to be 3 or 4 or 12, to kind of give a better indication of a more complicated hospital type of setup. We also have the planning document. The planning document includes references to specific chapter and verse on different design standards. It explains some of the design code, standards, minimums. It's actually written in the context of best practice, which to the most part kind of envelops and incorporates the minimum standards and codes and guides, that kind of thing. But most of that is baked in there. There's some specific values that we didn't want to include because your mileage may vary. You may be under different codes. We didn't want to be too prescriptive in that nature. And as I mentioned, we have the prototype suites. The suites are based on the VA sizes. They are a bit generous in terms of square footage, so you may choose to kind of squeeze them a little bit, but they are there. And the kicker, it's all free to download. All of these resources, the suite diagrams, the primer, there are also Revit files for the Metrasens products. All of that information is available in the Design and Construction Planner Resource Toolbox. So I'm going to tackle a couple of questions that come up fairly frequently when asking about different elements of MRI suite design. So the 2018 FGI and what will be in the 2022 require facilities to identify acuity levels. And so there's a level 1, 2, and 3, depending on the acuity of patient care. And then within that, we have to kind of superimpose zones 1, 2, 3, and 4. Actually, don't worry about zone 1. Zone 1 is spaces we don't care about. So you really only need to be dealing with zones 2, 3, and 4 for an MRI suite. So you may have a level 2 MRI suite, and then you got to kind of figure out how you do the zones. They are independent. We use 1, 2, 3 or 2, 3, 4 for the numbering scheme. But apart from the fact that they both use numbers, they represent different things. Let's look first at the acuity classifications scheme or structure. So this graphic is actually, it's taken from the VA's Imaging Services Design Guide, but the information in it is really based on the 2018 FGI information. And this is essentially sort of a table. And you go through this when you're planning a facility. And you say, what's the highest level of patient acuity we expect to serve in this MRI suite over its lifespan? Not only do you ask about the level of patient acuity, you ask about the level of patient sedation. Another way to say this is incapacitation. Now, are we just talking anti-anxiety meds, or are we going all the way up to full-blown general anesthesia necessary for life support because this patient is really injured and can't breathe on their own? Where in that continuum do we fall? And lastly, degree or level of intervention. We don't really consider starting an IV or natural orifice entry as an intervention per se, but maybe we're doing minimally invasive procedures, biopsies, or in a hybrid OR type of setting with an MRI, maybe we're actually doing full-blown open surgeries. So in each of these 3 categories, level of patient acuity, level of sedation, and level of intervention, we sort of figure out what's the highest level in each one of those. And whatever your highest of your highest category is the classification for that facility. And the classification will drive things like infection control requirements and air changes per hour and the degree to which you have to bring generator-supported emergency power into the room or medical gases and those sorts of things. So we may have a level 1 or level 2 or even an intraoperative hybrid OR level 3 facility. And onto that, we want to map the zones. And here's a different diagram of the zones. Zone 4 is always your MRI scanner room. And then zone 3 are areas of potential hazard or areas from which we can directly enter the MRI scanner room. Those are your zones 3. Zone 2 is on the outside of a locked door to keep people who haven't been effectively screened or prepared from coming back into the zone 3 where either they're in a hazard or they have access to a hazard. So the imaging acuity classification, class 1, class 2, class 3, which really map to exam room, procedure room, operating room. Class 1 is exam, class 2 is procedure, class 3 is surgical. That is independent from the zones, zone 1, 2, 3, 4. And again, zone 1 is all of the spaces that have nothing to do with MRI. So really, from a planning standpoint of an MRI suite, we're only looking at 2, 3, 4. Hope this helps to kind of clear that up a little bit. Door swings. Oh, this is another one that gets a lot of attention and anxiety. It used to be that the default RF door was a friction fit only door. It didn't latch. You essentially gave it a shoulder check to open or close it, or you had to give it the big yank if you were on the pull side of the door. And the only thing that kind of kept it closed in the closed position was friction between the edges of the door and the door frame. Hospital building codes have really frowned on latchless doors. They really, code officials really want doors that close and stay closed because they're really beneficial in reducing the spread of smoke and fire if the building catches on fire. So latchless radio frequency doors are fewer and fewer, and doors that positively latch are more and more. So the notion that the outward swinging door is just going to get pushed open when the pressure builds up inside the MRI scanner room really doesn't work with a latched door. And so having doors that swing whichever direction you want is okie doke. It's not a problem anymore. So swing the door either way. Swing it into the room or out of the room. In this particular illustration, the magnet room is on the left-hand side of the plan, and the control room is on the right-hand side. You'll notice in my text, I say, you can swing it either way, but swing it in to the magnet room. The reason I say this is that if you provide passive pressure relief, which the manufacturers all recommend you have passive pressure relief, and there are now design requirements in some places that you do this, then you've achieved the function that the outward swinging door was supposed to achieve in terms of pressure relief. So if you got that done somewhere else, you don't need to worry about the door swing. And swinging it in does two things for you. Number one, that corner of the room where the door usually opens into is usually not usable space. And so the door swing is essentially using unused space. Whereas control rooms tend to be really crowded, and swinging it into the control room uses a little bit of more valuable resource, or real estate, I should say. The second thing is by swinging the door into the magnet room, you actually reduce the potential for negative interaction between the radio frequency door and ferromagnetic detection systems. It allows you to dial up the sensitivity of your FMD without picking up, false positives kind of thing. I hate to call it that because we're detecting ferromagnetic material in the door. We'll call them spurious notifications. By swinging the door into the magnet room, you reduce those spurious notifications. So mount the ferromagnetic detector on the outside of the door And you get even better performance if you thicken the wall at the magnet room door just a little bit. This can be slapping a 4-inch stud or a 6-inch stud onto the existing wall construction and just pushing the ferromagnetic detector a little bit further away from the door. This is something that is called out in the new VA Imaging Services Design Guide. It's a detail that we love and we recommend every chance we get. And I would love to see you guys incorporate that as well. Now, all of this, the questions about acuity levels and zones and door swings and passive pressure relief and quench pipes and a whole bunch more, including an entire section about ferromagnetic detection and how to place it and site it and get the most bang for your buck out of FMD systems, whether they should be in patient screening and prep areas or at the magnet room door or some combination thereof. What about staff entrances and people coming in through the back door? How do we handle that? These questions and a whole lot more are addressed head-on in the new planner document. Plus, in addition to the planner document, as I mentioned, we have got the nifty 3D PDF models of the 3 different suites. I really wanted to show those to you. Unfortunately, the webinar platform really doesn't handle the 3D stuff very well. So go to the website. Now, you see the long URL at the bottom of the slide. You do not have to transcribe that and copy that. Just go to metrasens.com. And from the home page, you will see a link to the planner page, or you can go to the resources tab and you'll find a link to the planner page, or you can go to the existing architecture and construction reference page and you'll find a link to the planner page. All roads lead to Rome. Everything on the website will give you a pointer to get to here. All you need to do is fill out the little form that says, yes, thank you very much. I would like to have the free information. And they will send you a link that will let you get to the document, the planner document with sort of the collection of best practice bits about all of these issues. And many, many more than we've had a chance to discuss here. It will give you access to the small, medium, large, the outpatient imaging center suite prototype, the simple hospital, the complex hospital 3D suite prototypes. Download those PDFs. If you've never used the 3D PDF before, it will ask you if you want to trust the document, which you have to do before it will show you the 3D stuff. I guess some people can put malicious code in 3D PDFs. But if you trust the document, then it should show you the image, and depending on how strong and fast your computer is, there's a lot of information in them. It may be a little slow in manipulating it, but give it a little try and try it out. In addition to the 3 different suite prototypes, there's also Revit information, 3D CAD information for the Metrasens products themselves. So if you want to include the Metrasens ferromagnetic detectors in your architectural models, you can do that with the Revit information. A whole wealth of resource and information about MRI suite planning, both visual aids, references to standards and best practices, and sort of a narrative piece that is hopefully the Rosetta Stone that I talked about at the very beginning. It should speak clinical to the design and construction folks. It should speak design and construction to the clinical folks, and hopefully can help all members of a capital projects team for an MRI project all collectively be on the same page and all be working towards a unified vision of the best possible MRI suite. So, with that, I would really like to thank you for your time and attention. I hope that Number one, the webinar was helpful, but more than that, please go to the Metrasens website, request and download your copies of the planner resources, and look at those and feed back to me. Let me know if they are helpful to you in terms of gathering these resources from a bunch of different places and kind of bring them in all under one roof. And with that, we've exhausted our time. Brandon, I'm going to turn it back over to you and let you be master of ceremonies in terms of managing the Q&A session. Let's see what questions you've got.
Thank you for that, Toby. So just as a reminder, if anyone does have any further questions from anything they saw today or something that wasn't covered and they hoped was covered, please just submit it now. We'll try to get to as many as we can. We do have a few here. So the first one, some MRI vendor documents say that they require an MRI room door to swing out, but he says that's not important. How do we get vendor okay for an in-swing door? Very common question. Toby, I think that one's best for you.
Okay. So one of the interesting things, a disclaimer that you'll see on all of the OEM, and this is true for GE, Siemens, Philips, Canon, everybody, on their prototype documents, one of the disclaimers on their documents is these are not to be used for construction. These are for information purposes only. So first off, they can't technically tell you what to do with the construction of your building. All they can really tell you is, yes, we will sell you a magnet to put it in this room or not. Don't imagine that they have more authority than they do. We recognize that there are still some OEM siding guides, siding direction that say, you really should have an outswinging door. If you look deeper in all of the siding guides, they also, I believe, all today say you should have an alternative means of positive pressure relief. You should have what amounts to a room vent. So if the magnet quenches and if some of that cryogen spills out into the room and expands and pressurizes the room, it has a means to get out other than the patient access door. Once you do that, once you have that secondary means of pressure relief, then the door swing really no longer serves a safety function. So why do we care? So yes, the manufacturers sometimes will make a fuss about an in-swinging magnet room door, but as long as you take the other steps to provide the protection, then you're not compromising the safety of patients or staff or anyone else, and the manufacturer should be happy to let you swing the door whatever way you want to. What you got next for us, Brandon?
Well, actually, there was a follow-up one off that, so I think we'll do that one. Swing indoor, or inside door swing, just prefer if there is a passive air vacuum. Would you change your mind with that?
So you really should have a passive pressure relief system, a room vent system, not tied to an exhaust fan or anything like that. Essentially just sort of a ducted, louvered, way out of the room for gas in the room. An outswinging door, if you are bound and determined to have an outswinging door, that's cool, that's fine, you can have one. The thing you need to recognize is that as soon as there's a latch on the door, if God forbid, there's a quench and gases escape into the room and the room pressure rises, there's no way on God's green earth that you're going to be able to open that latched door. The pressure makes essentially it grips the latch in the door frame, and it makes it extraordinarily difficult to open that door. And if by some manner of amazing strength, you were able to actually open the door. Now you have a pressurized door, pressurized on the opposite side, that you have now released the latch on, and it is going to blow you across the room. That door is going to swing open with so much force that you are going to go flying to the far side of the room. It will be similar to being struck by a moving car, which is a risk factor in and of itself. So an outswinging door with a door latch is not a safety protection. There are still a very small number of RF doors out on the market that don't have positively latching doors. Your code, your building codes or hospital design standards may or may not allow those to be used. Your mileage may vary. So my universal recommendation is put in the passive pressure relief system, and then all of these questions associated with door swing really should disappear. And you can swing the door whatever way you want to. You can get latching, non-latching, whatever door system you want, because that is independent of the protections provided by a passive pressure relief system. What do you have for us next?
Thank you, Toby. Yeah, next question. You didn't talk specifically about accreditation requirements for MRI suites. What are those?
This could be its own webinar. So I'll speak to the United States. In the United States, we have two different general classifications of accreditation. There is enterprise level accreditation that is generally required of hospitals. So Joint Commission is probably the enterprise level accreditation organization that most people are familiar with. Also in the United States, the other classification or grouping of accreditation is modality level accreditation. Enterprise accreditation, as the name suggests, you are accrediting the entire healthcare delivery enterprise. That means administration, birthing suites, helipad, morgue, cafeteria, as well as, radiology and MRI. Modality level accrediting organizations accredit an individual clinical scanner. They accredit this CT, but not that mammography machine or whatever the mix is. So we deal with two very different schemes of accreditation. Joint Commission, and I'm just going to use Joint Commission and ACR because they're the most widely recognizable accrediting organizations from each of the two classes or groups. Joint Commission does describe in their diagnostic imaging standards something that sounds an awful lot like the ACR 4-zone. Now, they seem to go to great lengths to not actually reference the ACR and the 4-zone model, but the narrative, the text, pretty much describes the critical elements of the 4-zone, or at least, zone 3, zone 4. From an accreditation standpoint, if you're looking at hospitals, I would suggest that you use at a minimum the ACR 4-zone model, which is incorporated in the 2018 FGI and earlier versions as well, I believe. So that's kind of got you covered on the hospital side. On the outpatient imaging side, if you're using modality level accreditation, the requirements, the physical suite requirements are pretty ambiguous, unfortunately, from the accreditation organizations. ACR, for example, requires that a facility have appropriate signage and access control, but it never defines what appropriate is. And it never actually identifies that that is an explicit requirement of accreditation. So we're kind of left to our own devices to figure out what is or is not acceptable under modality level accreditation. Again, my recommendation is if you use the 2018 FGI, which incorporates the ACR 4-zone principle, you're pretty much covered at both the hospital and the outpatient imaging level with respect to accreditation requirements. So using one reference source, you kind of kill two birds with one stone. So I hope that that helps with that.
All right, thank you for that. Next one here, 5-Gauss line overlap with MRI equipment. Our fire marshal has asked us to move MRI equipment to clear the 5-Gauss line. Is there a code section that states this? Is there a code section that Gauss line over MRI equipment is okay? So in an existing construction environment, what would we do?
Okay, all right. So one of the interesting things about this situation that is described is a lot of times the entrance into the MRI equipment room or system component room is from a shared corridor, or from someplace outside the MRI suite itself. Now, the 4-zone model that essentially says to get into zone 3, you have to be screened, make sure there are no contraindications, and you have to, if this zone 3 space allows you to get into the MRI room, you have to be supervised by a level 2 trained MRI person. If we have an equipment room that's accessed off of a shared corridor or something that is not within the MRI suite, we don't restrict access to that corridor. And so theoretically, somebody moving from the corridor into the equipment room does not have to go through the MRI suite and the screening and supervision that's built in, theoretically, into the MRI suite. So what do we do, right? So a Zone 3 is defined by one of two different criteria. One of them is you can get from that space directly and unfettered, unrestricted into the MRI scanner room. So most often control rooms meet this criteria. The second criteria is there is an MRI specific physical hazard. Now the IEC, and the US FDA has adopted this, has said, hey, look, we're concerned about people who haven't been screened if they're exposed to magnetic fields that are 5 Gauss or stronger in field strength. So if your 5 Gauss line pushes into your system component room or equipment room, then that room is a Zone 3 space. How do we prevent people from entering a Zone 3 space? Well, you can have access controls. Those access controls can be physical, they can be operational, or a combination of the two. So as long as the room from that, or the door from that shared corridor, public access space, into the equipment room for the MRI that the 5 Gauss line goes into, as long as that door is locked, and the only people who have access to that door, have the keys to get in, are people who are screened by the MRI personnel, make sure that they don't have contraindications, then you have effectively provided the protections for those people. You don't have to make access to the system component room come through the MRI suite. You can do it outside. You just need to make sure that non-screened individuals can't get in there. And really, the only thing that should be in your equipment room or system component room is the equipment or system components for your MRI, which means the only people really going in and out of there with any degree of frequency would be the service engineers who are taking care of your MRI system. And those people are all going to be screened by virtue of their jobs to make sure that they don't have contraindications. There are no particular health risks. You don't want, the system component room to also be the housekeeping closet, to also be sort of a shared storage room, to also be, where the electrical panels for the entire wing are located. because then we have people who aren't MRI coming and going out of the room. But as long as it's an MRI equipment room and that's its purpose, then a lock on the door and MRI controlling access to who gets the keys, that's pretty much what you need. I hope that answers the question.
Great. Next one here. What are your suggestions for facilities that go from Zone 1 straight to a Zone 4 to help ensure safety?
Tear it down and start over. I mean that sounds harsh, but honestly, we can look at making temporary, incremental improvements to what is a bad safety situation, and absolutely we should do that. I don't want to make any bones about the fact that that is potentially a very dangerous situation. What I have seen done in different places, that ideas that I think may be good ideas, if it's in a shared corridor. So if you're walking down the radiology corridor, and CT is first door on the left and mammo is second door on the left, and MR control room is first door on the right, and the MR magnet room is the second door on the right. If you can kind of imagine that type of situation, you're really constrained in terms of what you could do. You can't build a little tiny Zone 3 vestibule because it's a corridor and then you have minimum corridor widths you have to maintain. So that might be impossible or at least very difficult. You can't make the door locked all the time. At least you can't make it so that it's locked so that the person inside the magnet room can't get out in the event of an emergency. There are special locking systems where the person on the inside can always get out, but the person on the outside can't always get in. That might be a minimum step to do. Do not go changing the lock sets on your magnet room doors, with in-house maintenance or facilities folks who are really good at changing locks and door hardware on other doors. But you need to make sure that whatever gets done to that door does not compromise its RF shielding capability. If you need the hardware changed, please reach out to your RF shield vendor to do that. At a minimum, you should have ferromagnetic detection as an entry, doorway entry system associated with that door. You can also look at the possibility of doing stanchions and ropes, not just for nightclubs, but you can essentially create a temporary boundary area, a Zone 3 space that is made with what amounts to movable equipment or furniture that will not get you sideways with your building codes and life safety codes, but can provide some minimal form of like a Zone 3 ante-room vestibule space that's not built out of walls and doors and that kind of thing. So those are a handful of interim suggestions. If you can't replace that MRI suite or can't make significant modifications to the construction, for example, to make the patient entrance to the magnet room come through the control room instead of through a shared corridor. If you can't do those things immediately, plan how you will be able to do those with some capital dollars, a new MRI system or whatnot in the future, and absolutely consider the interventions that I just described or perhaps others that might help you improve the safety situation in the near term. I hope that helps.
And with that, I think that's bringing us to the top of the hour. So I want to thank everyone for attending today. If you submitted a question and we did not get to it, please know we will follow up with you after and make sure that all questions are answered. Anything that you think of in future, please don't hesitate to reach out to Tobias or myself. And with that, thank you very much.
Thank you all very much.